In this lesson I discussed the basic force menu items. I open what we had last time. I will discuss which functions here are from interest for you. It's easier to put the or to see how it works with the forces, not to have active the mesh. I can activate and deactivate the mesh here in the browser, so I see more clearly what's happening with the forces. As we have seen, a force is acting on a surface, and I will find every entrance 2 times. We have loads, once in the load container and once we find it down there in the subcase, of a solution. So we have subcases and we have solutions. So in a solution you can have different subcases. Here is just one. Here, that's the application. If I take it out here, that will mean remove. It doesn't anymore exist, but the definition is there, as you see with this red circle, inactive. But I can every time take this force, transport it down to the load case, and once more I have this force active. Now that's how it works with the load container and case. Here in the load container is the definition, and here in the subcase area it's the application of it. So I redo a force as an example on this surface, and as you see, it's not only magnitude direction, but you can put it also normal on this face. If I give this 1000 Newton as an example on this surface, then it's normal on the surface. You see the direction is perhaps not that what you wanted. You can click it graphically and change this direction. One of the easiest ways is just to put in the minus sign. Okay, now we have the force up there. If you look at the force menu, you can also give directly the components. So the components are X direction, Y and Z direction. So you can put it once more on a surface and give as an example a Y direction. I give plus 1000 and you see the forces. I just make invisible these forces. You see if it's still there, just make it on the load container. Now I go on and I will work with the next. That was the force, that are force vectors, put it on a surface distributed to the nodes. Now you have also torque. Don't mix up moment with torque. For you only torque is of a meaning. Moment goes on to nodes, the rotational nodes. That's not existing in 3D, it's only on 2D, 1D, and we look much later on that. So torque is that what you suppose only on cylindrical surfaces like that. A torque can be applied. Be careful about the units. I just put in my 500 Newton meters and he puts that on this surface. Not really good visible, so perhaps it's better to change to the wireframe visualization, and you see how this torque is distributed. The torque will be distributed as forces on the nodes on these surfaces. We can change the representation of this torque edit display. You can scale it, and we can put up this number of points. I just take 20 there, apply, and you see it's a little more detailed. If it's okay or not, that's your decision. You can put the name on it. I go back and change to 10 in the both direction, and that's the torque. I go back to this visualization. So I showed you using a force, putting a moment, a torque on a cylindrical surface, and now we have the third interesting thing, a bearing load. So if you have a cylindrical surface, you just can say distributed on, as an example, 90 degrees. I introduce 5000 newtons in the minus z direction, and you see we have a distributed force, and it's distributed on just 90 degrees. We can go and change this. As an example, I say it's distributed on 180 degrees. You see it's changing. If the representation, the visual representation, is not good for you, just click edit display, and as an example, the size variation, you can put in more in one direction. So we have more in this direction, or more in the other direction. So we're getting more of these forces. So that's it. So we have seen good use for you: force, torque, and bearing. The others function, just forget it in the moment. It's just force, bearing, and torque. So that's all.